So this was a pop quiz which was related to electricity and magnetism. As we know, the resistance depends on the length. Resistance is directly proportional to length, so longer wires have high resistance than shorter wires. And resistance is inversely proportional to cross-sectional area. So thinner wires have high resistance than thicker wires. So the table describes four different resistant wire. They're all made from the same metal. Which wire has the smallest resistance? So if we want the smallest resistance, so we want a shorter, because if we increase the length, the resistance will be higher. If we decrease the length, so resistance will be smaller. So we want a shorter wire for a smaller resistance. So the wire must be short. And what about the cross-sectional area? Because if you want a low resistance, so it should have a greater cross-sectional area or it should be thick. So which wire is having which is thicker and which is shorter? So shorter, like 2 meter length is short and thicker is 1.5 meters. So B should be the right answer. Is it clear? That's one. Why B is the right answer? Then next is the diagram represents four copper wires. Which wire has the greatest resistance? So to get the high resistance, resistance is directly proportional to length. So we want a longer wire because longer wire will have high resistance. And it is inversely proportional to cross-sectional area. So thinner wire will have high resistance. So we want long and thin. So which wire is long? 20 millimeter is long, C and D. And which one is thin? So 1 millimeter is thin. So that's why C should be the right answer. So if we want to increase the resistance, we prefer to use a longer wire and a thin wire, longer and thin. If we want to decrease the resistance, we prefer a short and a thick wire. Next question. Student make 4 resistors using a different pieces of wire. The wires have different diameters and length. All pieces of wire are made of same material. Which piece will make the resistor the largest resistance? So we want a long and thin. So which one is long? Like either B can be an answer or D. But which one is thin? So 0.8 millimeters thinner. So that's why B is the right answer. So high resistance wire will be longer and thin. And low resistance wire will be shorter and thicker. Which circuit is which circuit could be used if you want to measure the resistance? Look, if you want to measure the resistance, resistance is actually a ratio between voltage and current. So if you want a resistance, resistance is a ratio between voltage and current. So to measure the voltage, we need a voltmeter. And voltmeter is always connected in parallel. To measure the current, we need an ammeter, and ammeter is always connected in series. So the position of ammeter is correct, but voltmeter is wrong. Here, position of voltmeter is correct, but ammeter is wrong. Here, position of voltmeter is also wrong and ammeter is also, because voltmeter should be either above or below an ammeter before or after. So here ammeter is correct and voltmeter is correct. That's why D is the right answer. Is it clear? Discussion? In question 5, a cylindrical conducting putty has a length L and a diameter D and the resistance R, and is now molded into a cylinder of a diameter 2D that has the same volume. By which factor does the resistance decreases? So how you can identify this? You can use a formula. You can use R1 A1 over L1 equals R2 A2 over L2. This is one way of doing this question. Or you can also use your understanding of the relation between resistance and length. Resistance is directly proportional to length, and resistance is inversely proportional to cross-sectional area. First, it was having a length L and a diameter D, resistance R was there. Now it has a diameter 2D. If a diameter is double, what happened to the area? Area will be 4 times. Why 4 times? Because area is equals to pi d square by 4. That's a formula to calculate the area. So if a diameter is double, because it is square, so area will be 4 times. Area will increase by 4. And if the area is increasing by 4, the length should decrease by 4. Why the length should decrease by 4? Because they mentioned it has the same volume. And so volume is area multiplied by length. If the area, when we double the diameter, area will be 4a, like 4 times. So if the area is 4 times, how we'll get the same volume? So the length should decrease by 4. Because the volume must be kept constant. The product of area and length must be constant. So if in the first part of a question, the diameter was d, so example, area is a and length is L. But then what we did, we doubled the diameter. If we double the diameter, the area will be 4 times. If area is 4 times, the length will be quarter. Why quarter? Because like if area is increasing by 4, the length should decrease by 4 so that the volume will remain constant. So here what happened? If the length is decreasing by 4, resistance will decrease by 4. Here what happened to the area? If area is increasing by 4, the resistance will decrease by 4. So because of change in length, it is decreasing by 4. And because of changing area, it is also decreasing by 4. That's why 4 multiplied by 4, it makes 16. So it means it will change by factor 16. You can do the question in this way. Why the volume should be same? It is mentioned in the question. They should have the same volume. This part is mentioned. So because they mentioned the volume is same, so means the product of the area and the length should be equal. So example, a cylindrical conducting, but it has a length L, diameter D, and the resistance R. So what about the volume? Volume is area multiplied by length. So when it has a length L, diameter is D, say area is A. But then we double the diameter. If we double the diameter, what happened to the area? The area will increase by 4. Why we multiply by, why area is 4 times? Because the formula for area of the cross section, it is pi d square by 4. So if the d is double, if d is double, what is the square of double? Square of 2. The square of 2 is 4. So the area will increase by 4. And if the area is increased by 4, what happened to the length? The length should decrease by 4. Why? Because we want the product of area and length to be constant, as they mentioned that it has the same volume. And then you use a formula, you can use a ratio. Resistance is directly proportional to length and resistance is inversely proportional to cross-sectional area. Because the length has to be decreased by 4, so resistance will decrease by 4. Because area is increased by 4, so the resistance should decrease by 4. So due to change in area, it decreases by 4. Due to change in length, it decreases by 4. So 4 multiplied by 4, that makes 16. That's why the resistance should decrease by factor 16. Is it clear, this question? So there is also another method to do this question. You can use a formula R1 A1 over L1 equals R2 A2 over L2. Where R1 is the resistance of the first wire, we say R. Area of the first wire, we said A. And the length of the first wire, we say L. R2 is the resistance of the second wire. A2 is the area of the second wire. If a diameter is 2D, area will be 4. Like it all, if the same question, if the diameter was 3D, then area will be 9A. If diameter is 4D, area will be 16A. If diameter is 5D, area will be 25A. Because it vary with the square. So if a diameter is double, area will increase by 4. If diameter is 3 times, area will be 9. Diameter 4 times, area 16. Diameter 5 times, area will be 25. So R1, R2, this is 4A. And the length, what about the length? Because it has a constant volume. If it has a constant volume, if the area is multiplied by 4, the length should be divided by 4. Because if the area is 4 times, the length should be quarter so that the product does not change. As they mentioned, they have the same volume. So here we can write L by 4. So now we simplify. When we simplify, area with cancel with area, length with cancel with length. This 4 is in a numerator. So when we simplify, and this is a denominator of a denominator, so this will be multiplied. So R is equals to 4 multiplied by 4, 16. So this will be 16 R2. And if we need R2, this 16 is multiplied, other side it will be divided. So R2, the new resistance, is 1 by 16 of the first resistance. So it is changing by factor 16. This is a second method in which you can use R1 A1 over L1 equals R2 A2 over L2. Is it clear, discussion? A student measures the potential difference across a device and a current, which calculation give the resistance. So resistance is actually a ratio between voltage and current. So when voltage is divided by current, potential difference is divided by current, we get the resistance. So C will be the right answer. With two changes to a metal wire increases the resistance. So if you want to increase the resistance, the wire must be longer, it must be thinner, and the temperature should be high. For a metals, resistance increases with temperature. So we must increase the length. Here, if we decreasing a length, that's wrong. Increasing the temperature, correct. Increasing a length, correct, but decreasing its temperature, wrong. Decreasing the thickness, when we use a thin wire and we increase the temperature, both cases the resistance will increase. So C is the right answer. Here, increasing a thickness will decrease the resistance, and decreasing a temperature will also decrease the resistance. So for a wire to have a high resistance, it must be thinner, it must be longer, and it should have a high temperature. How to work out the combined resistance of the circuit when two resistors are connected in parallel? So it will be a product divided by sum. So it will be 12 multiplied by 6 divided by 12 plus 6. So the combine of these two, 72 divided by 18. That is equals to 4. So this is 4 ohm. And this 4 ohm is connected in series because the combine of these two is 4 ohm. And that 4 ohm is next to 6 ohm, which are in series. So in series, what we do, we simply add. So 4 plus 6, that makes 10. So B will be the right answer. So whenever two resistors are connected in parallel, the combined resistance is the product divided by sum. When they are connected in series, the combined resistance is sum of individual resistance. So combine of these two, a 12 ohm and a 6 ohm makes a combine of 4. And that 4 is in series with the 6. That's why the total is 10. 4 pieces of the metal of a same material are connected in turns between points. The table gives the diameter and the length in which the current is largest. So current, for a high current, we want a low resistance. How we can have a low resistance? So we should use a short wire and we use a thick wire. So the wire must be shorter, so either like 1 and 1, and the wire must be thick. So 0.2 is thicker than 0.1, so C will be the right answer. Here, no need for calculation. You just use an idea. If a diameter is small, the wire will be thin. Diameter is large, then wire will be thick. In question 10, the resistance of a component in a circuit is found by using ammeter and the voltmeter. How are ammeter and voltmeters are connected? So voltmeters are always connected in parallel and ammeters are always connected in series. So C will be the right answer. Question 11. Identical resistors are connected together. What is the correct order? Look, if they say identical, you can take any value. Like value is not given, but for your understanding, you can take a value, say this is 2 and 2. Like all are 2. As I mentioned, they are identical, means they are same. So what is the combine of these two? It will be product divided by sum. So 2 multiplied by 2 divided by 2 plus 2. So the combine of this one will be 1 ohm. What about the combine of these two, 2 plus 2, which make 4? And these 3 resistors are connected. So 2 plus 2 plus 2, which will make 6 ohm. So what is the order of a resistance arranged from a largest to the smallest? So Z, then Y, and then X. Okay. So Z, Y, and X. Or a simple idea, when resistors are connected in series, the total resistance increase. When they are connected in parallel, the combined resistance will decrease. So you can take any value. I took 2, you can take 5, you can take 10 for each of them. You will get the same answer. It won't make difference. Like you will get the order will be same. The final result will be different, but the order of X, Y, and Z will be same. Is it clear, this question 11? Then we have 4 wires are metal of are made up of same metal. Uh, which wire has the greatest resistance? So it must be longer and thinner. So 100 centimeter long, and it should have a smaller diameter to have the high resistance. So this is having a smaller diameter and it's a longer 100 centimeter. So A should be the right answer. So longer wires and thinner wires are having high resistance than thicker and shorter wire. So this was electricity and magnetism pop quiz 2. Any other question or doubt from this?